Hi, this is Professor Schwitkus, and we're going to talk about calipers today. A caliper is basically a device that's going to allow you to measure accurately objects within their jaws. So this is something you can measure the outside uh, diameter of something or the thickness of something. Here is a ring, and I can measure the outside diameter of it by doing something like this. I could measure the inside diameter by doing something like this, okay? And then you can see how I'm manipulating this tool around. And the nice thing about this tool is it allows me to measure pretty accurately just what it is that I'm measuring, okay? So here it is. I've tightened down the screws just a little bit, just snugly, not really torquing it down. And if you look here, you can see hopefully some of the measurement, the scale. Okay, so here is the scale that is referred to, and the vernier is basically this little tidbit right here. Okay, and you're going to be comparing the scale on this side versus the scale just above it. And it turns out that this particular caliper has two different types of measurements. I think it's metric on the top and it's English on the bottom here. So you got two different scales there. Another example of a vernier caliper is in the use of a sextant. And here you measure off the actual degrees on this thing. It's an angle measuring device. And right here, you can see, hopefully, you have an inside scale and an outside scale. And by combining those two together, you can get measurements that are within to 2/10 of a minute of accuracy. Now, mind you, the error associated with your measurement is going to be dependent upon the accuracy of your tool and the how well you've reproduced your measurements, okay, and any dumbass mistakes that we have a tendency to do. Now, for this guy, the indication of the accuracy of the tool is right here, and I think it's like 0.2 millimeters is what I was using. Okay, so what you want to do in taking these measurements is basically you're going to try to make your measurements do it as many times as you have time to do it. So I normally say at least 3 times, okay? That will give you a standard deviation when you calculate one, and 2 things will give you an average. So at least take 3, and if you've got time, take more. So if I was going to, this is one of the experiments you guys have you do, which is determining the density of these materials and then figuring out what they are made out of. So what you need to do is measure the mass and measure the volume. So the length for a cylinder and its diameter will tell you the volume, right? Simple calculation, pi d squared over 4 times the length. And what I'm indicating here is not measuring the radius or calculating the radius. Use the measurements themselves, figure out the averages of the measurements, because the average is your best estimate of that parameter. And then you've got a good indication of what that parameter is. So in this particular case, since I'm after volume, I first take the diameter measurement, read what that is, put it in my spreadsheet or my notes, then I come over here and then take a measurement of the length, and reading off the scale however long it takes, and then doing it again. Okay, so it's basically this, and then coming over and doing the length again, and then coming over here and doing the diameter again, and then finally ending up with the length again. And I'd go through this cycle 3 times at least. If I wanted to get more measurements, I'm going to get a better accuracy, but it will take more time. So that's, in a sense, how you go about using a pair of calipers. I don't know if that's the appropriate term, but at any rate, the idea is always to take your time, okay, and take the measurement, do it cyclically. So you measure one thing, you redo the entire setup over again. So, first measure the length, then come over and do the diameter, then redo the length. And you can see I'm doing big movements, and I'm really changing the value of the caliper. It isn't like I'm coming over here and doing this, and then redoing it like this, or even better yet, okay, doing this and just saying, okay, here's the number, and then look away, and oh, here's still the same number. I don't think that's an independent measurement. So, with that in mind, we'll try it next, we'll see you again. Adios.